Hi. In this video, we're going to see how to calculate arithmetic mean returns and geometric mean returns, which are also called buy and hold returns. Understand what is the difference between the two of them and kind of pave the way for what we're going to be doing with returns and risk in this program. So if you don't mind, I will bring up some notes to share with you. And this is from the risk and return class notes. This is on page 2. And what we're going to do is we're going to take a look at the formula first for calculating an arithmetic mean return. And we see that what we do is we add up, this, I think everybody knows this, we add up all the different returns and we divide by t. That is the number of returns that we had. And let's take a look at it as an example here. Let's suppose you asked me to manage your money for you, and you asked me to manage it for 4 years during the years 2001, 2002, 2003, 2004. Just make it matter simple. And suppose in 2001, we had a 5% rate of return. You gave me $100 to start with, and we had a 5% return. During 2002, I continued to manage your money, and in 2002, your money gained 9%. In 2003, I didn't do so well managing your money. It went down by 12% in 2003. And in 2004 was a very good year. It went up by 20%. So how do we calculate the arithmetic mean of those returns? We're going to simply add those numbers together. And it's easiest to do it as decimals. It doesn't have to be done as decimals, but it's usually easiest that way. So we add the 4 returns together, divide by the number of 4, and we get 5.5%. So that's pretty simple. I think everybody kind of knows how to do that. But there's a problem with that. And let me show you what that is by bringing up the whiteboard. If I bring up the whiteboard, what we're going to see here is that if I've got this money to manage for you for these 4 years, here's times 0, and you give me $100. Now, as we saw, in the first year, the money goes up by 5%, right? So at the end of the year, you're going to have $105. During the second year, that money goes up by 9%. So 105 times 1.09 is going to give us $114.45. That's how much money you have at the end of the second year. At the end of the third year, what are we going to have? $100.72. Why? Because $114.45 lost 12%. So it's like multiplying it by 0.88, and then you get the $100.72. And then during the fourth year, it went up by 20%. So $100.72 times 1.2 is going to give us $120.86. And so that is absolutely correct, that if we start out with $100 and got those returns for the 4 years, this is what you would end up with. So I send you a letter at the end of the year, and I say, hey, I got good news for you. We did pretty well for the 4 years. We averaged 5.5% per year, and you ended up with $120.86. And so you decide to use some of the finance that you learned in your first finance course, which was that future value is equal to present value times 1 plus r, the interest rate per compounding period, raised to the t power, which is the number of compounding periods. You may have used different symbols other than r and t, but that's how you find the future value. So you remember that you sent me $100 to begin with. That's what you gave me to manage. And you noticed in the letter that I said I averaged 5.5% per year. So that's 1.0551 plus 5.5% per year raised to the 4th power. And you do the math on that, and you find that that ends up giving you $123.88. And you come to me and say, wait a second, how is it that you tell me there's $120.86 in the account when, if we average 5.5% per year for 4 years, there should be $123.88. Therein lies the problem with the arithmetic mean. It's not going to be a good representation of what actually happened over those 4 years. Indeed, as we saw, if we had those returns of 5% during the first year, 9% the second year, negative 12% during the third year, and 20% in the fourth year, you would truthfully end up with $120.86. But the arithmetic mean overstates that by saying that you would have had $123.88. Let me give you an even more extreme example here. Let's suppose, again, you give me $100 to manage, but this time it's only for 2 years. And in the first year, things don't go well. Your money gets cut in half. And so that is a negative 50% return during the first year. So your money goes down to $50. However, things got better during the second year. Well enough so that your money doubled. It went from $50 back up to $100. So in the second year, you got a 100% rate of return. If your money doubles, that's a 100% rate of return. So the first year you lost 50%. The second year we gained 100%. And so I decided to tell you what was the arithmetic mean. Arithmetic mean, we add these two numbers together. Negative 50% and 100%. When you add them together, you get 50%. Divide by 2 and you get 25%. So the average return, arithmetic mean for those 2 years was 25%. Now, if I told you at the end of 2 years that I averaged 25% return per year, you would have thought your money really grew and did very well. But as you can see, your $100 at the end of 2 years was still $100. And again, that is why the arithmetic mean is deceptive in terms of averaging past returns. So we don't want to do that. In fact, it's illegal for professional investment managers to report returns this way as an arithmetic mean. So what we're going to do instead is we're going to look at the geometric mean. And so how do we calculate the geometric mean? Well, let me first of all clear this off a little bit. So with the geometric mean, what we're going to do is we're going to add 1 to each of the returns. So the first year's return was 5%, add 1 to it, it's 1.05. And we're going to end up multiplying them together. The second year's return was 9%, so we got 1.09. The third year's return was negative 12%. 1 plus negative 12% is 0.88. And the fourth year, we had 20%, add 1 to that is 1.20. So we multiply them all together, means take the product of them, and then we raise them to the power of 1 over n, n being how many years we had. And in this case, it was 4 years, so we're going to raise that to the 1/4 power, and then we're going to subtract 1 from that. That's how you get the geometric mean. You add 1 to each of the returns, multiply them together, raise it to the 1 over n power, and then subtract 1. And if we do that, we find that the geometric mean is going to be 4.85%, less than the 5.5% we got from the arithmetic mean. But if we do our formula that the future value is equal to the present value, $100, times 1 plus r, plug in 8.85% for r, 1.0485 raised to the 4th power. Guess what we're going to get? We're going to get $120.86, which is indeed what you had at the end of the 4 years. So that is how investment managers must report an average of past earnings with the geometric mean. Let's do the same thing with our example of $100 for 2 years, where we have even more extreme returns. If you recall, time 0, we started with $100. At time 1, it went down to $50, and at time 2, back up to $100. So we lost 50%. Add 1 to negative 50%, and you get 0.5. The second year, we had 100%. Add 1 to 100%, and you get 2. Multiply them together. 0.5 and 2 is 1. Raise that to the 1/2 half power, which is the same thing as taking the square root, and you still have 1. Subtract 1, and you get 0. So the geometric mean was 0, which is a pretty good indication of what happened when you started at 100% or $100 and we ended at $100. So the geometric mean must be used, okay, when we're showing here's what the average returns were in the past. Now, the geometric mean will always be less than the arithmetic mean unless you had the same returns every year. Like if you had 10%, 10%, 10%, and 10%, you average them together, arithmetic mean, it's 10%. You average them together, geometric mean, it's also 10%. But as long as there was some volatility in the returns over the different time periods, the geometric mean will be less than the arithmetic mean. In fact, the more volatility you have in those returns, the bigger the difference will be between the geometric mean and the arithmetic mean. Now, this doesn't mean we just throw out arithmetic mean and say, it's no good for anything, we'll never use it. Not true. We do use the arithmetic mean when we're talking about expectations of future returns. And we also use the arithmetic mean when we're calculating variance. And as you probably know, variance is a measure of volatility. Okay, a very little bit of variance, we're going up and down like this. A lot of variance, we're going up and down like this. Standard deviation measures the same thing. So the arithmetic mean is the return that we're seeing, how much the returns went up above and down below. If the different data points go way up above the mean and way below the mean, that is going to be a high variance. If they go a little bit above the mean and a little bit below the mean, that's going to be just a little bit of a variance. But it's the arithmetic mean that we use here. So in our next video, we will show how to calculate variance for this exact example here with the 5%, 9%, -12%, and 20%. We'll see how to calculate variance and then how to take the square root of that, which will be the standard deviation. But you'll notice in there that we are using the arithmetic mean of 5.5% when we're calculating the variance.